Hello students, welcome back. So now we are going to be performing univariate analysis on numerical column. More specifically, we're going to be dealing with distribution analysis. So the first thing I'm doing, I'm importing my necessary libraries right here. And now I read my CSV file. So this is my data mpg.csv. Or if you want, you can read the pickle file if you have done the step one. So in this case, I'm reading my MPG file, which is my CSV file, and I'm printing 10 sample values just to see what my data looks like. So this is how your 10 sample values are. It kind of gives you a feel of your data. So let's look at the descriptive stats real quick. So this actually was covered in the previous section, so I'm not going to cover this too much. So this is my numerical column right here. And in this numerical column, I'm actually printing out my describe, and that gives me descriptive statistics for these numerical column right here. So let's start with the histogram first. So in this case, first thing I'm doing is I'm choosing my palette and font scale. So I like my background to be dark, and I want the colors to be gold. I'm just a gold kind of guy, and also I want my font size to be 14, and changing my choosing my statle size, label size, and everything. Then after that, when I run this cell, this gets activated. So first thing I'm doing is plotting histogram for only one column. In this case, and the column I'm choosing is MPG, miles per gallon. I'm also importing Seaborn. This is a good library. It kind of gives you a good visual feel to your graph. So that's what I like about this library. So I'm importing that library, and then I'm calling this hist plot for that. This is an inbuilt method inside your Seaborn library. So in this case, I'm specifying that create 10 bins, and I also want to see my KDE plot. And this is the color that I want, gold, and my edge color, that would be these edge colors, I want them to be white. Also, I'm giving some transparency, alpha equal to 0.8. So by the way, KDE stands for kernel density estimation. And then I'm plotting my curve, and I want it to show. So when I run this, it prints out plots this particular MPG curve. And let me decrease the size of the screen so it's a little bit more visible. There you go. So you can see that your curve actually is going like this, something like that. And if you remember from your descriptive stats from your previous class, that if you recall that that your data lied between, I think there were some values. So I think there were between. Let's go back and check. Your MPG was lying between 9 and 46.59. So minimum range was that. So you can see that you're 9, all right, that's good. And 46 would be somewhere, let's say 40, 46, yeah, somewhere over here. So most of your data is lying between here and here. Not most, but this is the range from minimum to maximum. Okay, visually, it seems that most of your data lies between 14 and 30. You can see that this is 10, so your 14 would be somewhere over here. So most of your data is in this range right here, between 14 and 30. That's where your majority of data lies. And then it also seems like your minimum 9 to maximum 46.6 seems to agree with the above curve. Okay, we saw that. Also, your average 23.5 also agrees with the above plot. So 23.5, if you recall, that's the mean for your MPG. So 23.5 would be somewhere over here. So that lies somewhere in this place. All right, let's just go 23.5 was mean for your MPG. Okay, so it kind of agrees with your curve. So we're just making sure that whatever we saw in our descriptive stat, it agrees. So after doing for one column, now I can actually do for each one of the columns separately. I can create a different cell, or I can just run a for loop. So in this case, I'm choosing the for loop. So I'm iterating through each one of these columns, and I'm plotting histogram or hist plot for each one of them. So after I plot this, you can see that this is for, let me just decrease the size of the screen again. There you go. So this one is for miles per gallon, and this one is for your displacement. So as you see, there's a displacement. So this is for displacement. Let me just come down here. The displacement right here. This one is between horsepower. All right. So you can see between horsepower and count. So your horsepower actually goes like this. This is a curve. Then you have this right here, weight, and then you have acceleration. Let's deal with one of them. So you get some idea what's happening. So in this particular instance, let me just go. Yeah. So here you can see that your acceleration in this particular instance is going from 7.5, or I would say 7.5 maybe, to 25.0. And look at that, it's perfect bell-shaped curve. So this is your mean value. Okay, mean value I would say is 15 for acceleration. So if you go back on top and if you try to look at the mean value for your acceleration, it should be coming out to be somewhere around 15. Let's see, acceleration and your mean is 15.5. That's pretty much on the mark. Okay, so this way you can draw these conclusions for each one of these curves right here. And now if you want the KDE separately, which is kernel density estimation curve separately for each one of them, you can do that too. So in this case, I'm specifying my column equal to MPG, and I'm plotting my KDE, just KDE plot. And you can see that it plots the KDE for MPG. So in this particular instance, you can see the values goes from here to here. Most of your data lies between here to here. You can kind of gives you a little sense that this is where your bulk of your data is. Let me just decrease the size again. There you go. So most of your data lies between, let's say, between this range to this range. Kind of gives you an idea. Uh, Now we can do KDE for all numerical columns. So in this particular instance, I'm going through each one of the columns and I'm plotting the KDE, and you can see that this basically plots the KDE. So it kind of gives you an idea how your data is distributed. For this one, it seems like most of my values are between here to up to here, and then you can see the value was going down. Then all of a sudden there was an increase and down. Okay, and then look at this one. So it seems like your value goes up. Okay, there was a lot of data over here between 50 and maybe 110. Then it actually went down. Then all of a sudden there was a little dip, there was a little uptick, then it went down. Okay, this right here tells me that most of my data is between I would say 500 to maybe somewhere 4,000. Yeah, maybe 4,000, something like that. Okay, you can also check for skewness. Skewness basically tells you how much your data is skewed. In other words, how much your data is away from normal distribution. That's what it tells you. So let's select our numerical columns, and in pandas you have this skew inbuilt method. All you have to do is just call the skew on the numeric columns, and that's going to print out your skewness. So these are my skewness for each one of the columns. For MPG, this is the skewed value. For horsepower, this is the skewed value. Well, how do you read this thing? Well, this is the criteria that's used. So if your value is very close to zero, that means your curve is very symmetric. On the other hand, if your value is more than zero, then it means it's right skewed. Otherwise, if it's less than zero, it would mean left skewed. So let's look at this value right here. So in this case, you can see that your acceleration, 0.27, this one is more closer to zero. Okay, very close to zero. So this is almost symmetric. That's what it means. So if you come over here, and in this case, I'm plotting my KDE for acceleration, and you can see that acceleration curve. Look at that, how symmetric that is. Very symmetrical. Okay, let's look at the other one. In this case, horsepower. So if you look at the horsepower, it is 1.09, way off than zero. It's like right skewed. Okay, it's greater than zero, so that should be right skewed. So let's take a look at this thing. Come down over here, take a look at horsepower. So I do KDE for horsepower, and you can see that it is right skewed. It goes up like that, and then it comes down, and it tapers like this. So generally, your right skewed curve, they would have a shape like that. Okay, your left skewed curve will have a shape like that, something like that. Okay, so yeah, thank you.